Alright, so here we are on to the glider question. A glider is launched from a tower that sits on a hilltop. The height h in meters is negative whenever the glider is below the height of the hilltop. The height of the hill is 40 meters above sea level. Sorry, there's a word missing there. The equation representing the glider's flight is this, where t is the time in seconds. So first of all, let's try and understand what this question is talking about. Okay, so it says a glider is launched from a tower that sits on a hilltop. So there's a hill, and there's a tower. So there's my hill, there's my tower. And it tells me that the height in meters is negative whenever the glider is below the height of the hilltop. So what that's saying is that this is 0. And so we're going to put our axes like this. Okay? This is time, and this is height. So this is defining 0 right here. Anything below this is negative height, anything above that. And it also says that the hill is 40 meters above sea level. So we'll just make up some kind of sea level here. Here's my water. So that's telling me that that is 40 below 0. So here's the height. Alright, so what happens is I launch from here, and I can tell by looking at this, this is opening up because there's not a negative value here. So it's going to look something like this. I launch from here, I go down, I swoop down almost like a bird swooping down, something like this. Alright, so I have my starting point, which is my y-intercept. This is where I start. Intercept. And I have my vertex down here. And let's see what, and there's 2 points here. I don't know if I need them, but there would be 2 points where I would go below h is equal to 0. This would be the top of the hill. So let's see, how tall is the tower? Okay, well I got launched from the top of the tower, so that's just my c in standard form. Which it is in standard form, so right there is the height of my hill. Right here. Or sorry, height of my tower on top of the hill. Alright, at what time did the glider reach its lowest point? For that one, I'm looking for the vertex, so I will need to complete the square. It says, how high above the sea level is the glider when it reaches the lowest point? So in part C, I'm actually looking for this height, how high above the sea level. So let's go ahead and complete the square and do that. So for A, the tower is 12 meters high, or tall. That's from the C in standard form. And B, we're going to need to complete the square. So let's go ahead and write this down. Make sure we write it down properly with all the signs right. Oops, forgot a 4. And if you want to change it to x and y, you can. The problem is here, I just know when I'm looking at if it's t, then I know it's time, and height is h. So let's go ahead and separate. You don't want to factor the 12, so you're just going to put that to the side. Here we're going to factor out a 0.25. We don't have to worry about doing signs because that is positive. So that's going to become t squared. We're dividing by 0.25. That's like multiplying by 4, but if you're not sure, go ahead and do that. Take 4 divided by 0.25 and you'll see it's 16. It's the same as multiplying. But don't forget this is a negative sign here, so this is 16t. Alright. Leave space to do our adding and subtracting, and throw our plus 12 in there. Alright, so I'm going to take this number. I need to add a number to make it a perfect square. I'm going to add half of this. So that's negative 8 all squared. And then I'm going to subtract the same thing because I don't want to change it, really. I just want to rearrange it. So go ahead, h is equal to 0.25, square brackets. Alright, what does this become? This becomes a perfect square of t minus 8 all squared. 8 times 8 is 64. Close the square brackets, plus 12. So now I need to distribute this 0.25 in front of the brackets. That just goes, and then this is going to stay minus. Again, if you're not sure, use your calculator, but I mean it's 64 divided by 4, which is 16. And then we have our plus 12. We don't have to multiply the 0.25 times that because this only applies to what's in the square brackets. And I'm left with h is equal to 0.25 to t, and I'm going to do the math here. This is going to be minus 4. Alright, so what does this tell me? This tells me that my vertex is at -8, -4. Oh no, not -8, because remember that's that negative there. So t minus 8 equals 0, right? That's when we want to know it is. I mean, that's kind of what we were doing before, but we just know that the standard form, if you've forgotten, y is equal to a x minus h all squared plus k. Alright, so this standard form is for a negative there. Alright, so what does that mean? This is time, and this is height. So if I go back up here, alright, that means that here, this would be at 8 seconds, and this would be down to -4. So my scale is way off, but that's okay. Alright, that's what that means. So therefore, he was asking me at what time did the glider reach its lowest point. The glider reached the lowest point 8 seconds after launch. C asks us how high above sea level is the glider when it reaches its lowest point. So I wanted to know between here and here. So if this is -4 and this is -40, I want to know how much space is between there. Well, what's the space between 4 and 40, right? Is 36 meters. So therefore I am 36 meters above sea level. So that's for C. Okay. So therefore the glider, can you guys see that? The glider is 36 meters above sea level.